Today we'll apply simplifying expressions to solving simple equations using the properties of equality accurately. And we're going to solve equations that have variables on both sides. So here we have 3x plus 2 equals 2x. So what our goal is to get all the x's on one side, everything else on the other side, and then solve for x. So I have this 2x. I want to bring it over here with the 3x. So I'm going to do that. So this is positive. I need to do the opposite, which is negative. What I do to one side, I have to do to the other. So 3x minus 2x is just x. This plus 2, we didn't do anything to it, so we keep it the same. And then 2x minus 2x is 0. Now I need to move this 2 over to the other side. Since it's being added, I'm going to subtract. So x equals negative 2. All right, let's look at another example here. All right, so now we have a bunch of different things going on. So I want to simplify each side of the equation. For this side, I have this x and this x that I need to combine because I'm combining like terms. So I will have negative 3, and then negative 5 plus 4 is just negative 1. So negative 3 minus x. Then I'm just going to rewrite this side here. Now this negative 3 right here, I need to distribute to both pieces of the parentheses. Oops. So negative 3 times 7 is negative 21. Negative 3 times negative 3 is 9. And this 2 is negative. All right. So then I need to combine these like terms here. Now I need to get my x's on one side and my other numbers on the other. So I'm going to add x, get rid of that. 9x plus x. Then I'm going to add the 23. So negative 3 plus 23 is just 20. These cancel and I still have my 10x. Since 10 is being multiplied, I'm going to divide. So 2 equals x. So my x is 2. Okay, so we've been looking at equations that have a solution. So there are two other types of equations. There's an identity, which is an equation that is true for all values of a variable. So it doesn't matter what you put in for x, it'll always be true. And those kinds of equations have infinite solutions. And then you also have equations that are false, and false equations have no solution. So let's look at a couple of those examples. Okay, so we have 3x plus 4 plus x equals 1 plus 4x plus 3. So let's start by combining our like terms here. We have 3x and x. When you add them together, you get 4x plus 4. And on this side, you have 1 plus 3, which is 4x plus 4. So you look here and you see that this is the exact same thing. 4x plus 4 equals 4x plus 4. But even if we went a little bit further here and moved our x's to one side, you get 4 equals 4. This is a true statement. It doesn't matter what you put in for x, you will always get a true statement here. So this would be an identity, but it has an infinite number of solutions. All right. Let's look at another example here. We have 4x plus 16 equals 3x plus 4 plus x. All right, we're going to combine our like terms here. This stays the same. 3x plus x is 4x. I subtract 4x from both sides. And I get 16 equals 4. That is not a true statement. This is false. So there is no solution. If you'd like more practice for this, you can go to IXL in the Algebra 1, J6, 7, and 8. Those sections there would get you a lot of practice on these types of equations. And I'll see you in Zoom.